So that would be negative log of hydroxide, which is POH, and then we would just simply flip it to pH. So 4 areas of the curve that are used really just by stoichiometry to determine pH of a solution at any point in time. Let's model with a sample problem. We are going to calculate the pH for the following quantities when 0.1 molar sodium hydroxide has been added to 50 mils of the 0.1 molar HCl. So equal concentrations, but I'm noticing before and after in terms of the endpoint. Exactly 50 mils, pH would be 7. That would be equal number of moles of sodium hydroxide and hydrochloric acid. So if we had equal amounts, 50 and 50, the pH would be 7. So I would suspect at 49, the pH will be below 7. If you overshoot the endpoint, the pH should be above 7. Let's indeed check our theory. Let's start by considering the stoichiometry. If NaOH is being neutralized by HCl, we understand sodium chloride and water are the products, and this salt does not undergo hydrolysis. So therefore, it has absolutely no effect on the pH of our solution as it's forming. We know we have 0.1 molar of the base, and we're going to put in 49 milliliters of the base. 0.1 molar acid and 50 mils of the acid. Let's do molarity times liters and determine the number of moles and consider the stoichiometric ratio. 0.1 times 0.049 liters gives us 0.0049 moles of the base. 0.1 times 0.05 liters gives us 0.005, and think of that if you'd like to, 49 and 50 in millimoles. What we're noticing is the perfect ratio is 1 to 1. We have 49 millimoles compared to 50 millimoles. We do not have an equal amount, so therefore we have a limiting and an excess reagent. We understand reactants get used in the same ratio. So if we label the smaller of our two answers as a limiting reagent, think of this as before and after the reaction. If 49 millimoles of base are added to 50 millimoles of acid, the acid is in excess amounts. We can simply subtract to find the number of millimoles in solution. 0.0049 from the 0050 gives us the number of excess moles of the acid. 0.0001 moles of hydrogen ion. When I think about writing that in terms of scientific notation, that is 1 times 10 to the negative 4th for the hydrogen ions in excess amounts, and therefore I can hit directly 1 times 10 to the negative 4th, and a pH of 4 comes out. Well below the pH of 7 at the neutral point. So even though that's a tiny number of moles, we still are below the equivalent of 7. If we think about what's happened after we shoot the endpoint, if we added 51 mils of base, again considering the stoichiometry, we see that if we added 0.1 molar and it was 51 mils compared to the 0.1 molar of 50 mils, and again considering the stoichiometry, we have 0.050 moles of acid, molarity times liter. And we'll do the same here, 0.0051 moles of base. Perfect ratio is 1 to 1. Now I'm considering a new scenario. It's the acid that is the limiting reagent. It is the smaller of the two numbers. So after the reaction, it's gone. And along the way, it's used up 0.0050 moles of the base, leaving us 0.0001, or 1 times 10 to the negative 4th moles of excess base. However, if I take negative log of 1 times 10 to the negative 4th, that gives us something called POH. The excess amount here is the base. So if POH, 0.001 times 10 to the negative 4th, gives us a POH of 4, the pH comes out to be 10, 14 minus there. So just to consider what's happened. Right before the end point, we are still pretty low on the pH curve. If indeed we had equal amounts of acids and base, pH is 7, but a little bit more base and we see it shooting up all the way to the pH of 10 pH units. So therefore, a significant difference in pH from 4 to 10, which validates that steep slope going from volume of 49 to 51, and we see a rapid rise in the pH. To repeat, if we had 50 mils, that would be an equal number of acid-base moles, no limiting or excess reagent. There is no math to show pH is exactly neutral of pH unit 7. That's the case when, had I delivered 0.1 molar 50 mils of strong base with 0.1 50 mils of strong acid, they are equally consumed. The only thing determining pH then is the water, and it's said to be neutral at 7.0.